idea that in a circle, two minor arcs are congruent. So what they're saying here is that AB is congruent to CB if and only if the chords are congruent. Okay, and you can kind of see it, it's a little bit faint, but they do have a tick mark here that AB is congruent to CB. So if the chords are congruent, the arcs are going to be congruent. All right, so if we understand that concept then, arc AB is 3x plus 11. Arc CB is 2x plus 48. How can we solve for x? And then how do we answer the question of finding the length of, or the measure of CA? Ideas? Set them equal to each other. Okay, so 2x plus 48 is equal to 3x plus 11. Subtract the x over, you get x, because 3 minus 2 is 1. Subtract the 11 from 48, and what do we get x to be? 37. Okay? All right, are we done? No. What do we got to do? Plug it in. So what is 3 times 37 plus 11, or 2 times 37 plus 48? What'd you get? 122? 122? Okay. We got two people saying it's 122 and 122. Okay? Is 122 the answer? No. It says to find the measure of CA. It wants us to find this arc. Now what? Very good. 360 minus 122 minus 122. Remember, the entire circle is 360 degrees. Subtract off the two arcs. 116 degrees. Okay? So again, a good question. Literacy skills. Make sure that you're always double checking the question and answering it. All right? Questions there. All right? Next theorem. If a diameter is perpendicular to a chord, okay, notice that AB is passing through C, okay, it's passing through the center. That means that AB is the diameter. FE is the chord, okay? If a diameter is perpendicular to the chord, it bisects the chord. All right, just to make sure that you understand this concept, okay, you don't have to draw this. I'm just going to point something out, okay? Let's say I draw a chord, okay? And I draw any line perpendicular to it, like this one. Did I cut the black line in half? No. Okay? What if I move the chord over here and it's still perpendicular? Did I cut it in half? No. The only way that I get it cut in half is if I have that chord passing through the center. Now it looks like the left side is equal to the right side. Okay? So you have to understand that it has to pass through the center, it has to be a diameter, and it has to be perpendicular. Okay? Again, if you want to, we can go through the idea of showing, hey, if I were to draw on these, I can prove that the two triangles are congruent, making it bisecting. Okay? But we shouldn't have to necessarily do that. All right? All right, so big idea. Number 2. If one chord is perpendicular bisector of the other, then the chord is a diameter. All right, so big concept. You need three things all the time. You need perpendicular, and you need diameter. Sorry, you only need two, and then you can assume the third, okay? Perpendicular, diameter, and then bisect, okay? So if you have two out of those three things, you can assume the third, okay? So if I have a diameter that is perpendicular to a chord, then I know it bisects the chord. If I have a diameter that bisects a chord, then I know that it is perpendicular, okay? If I have a line that is perpendicular and bisecting, then I know that that line is the diameter, okay? So you always need at least two out of these three things, okay? Big idea. And that's why there's essentially two theorems with it. The first one says diameter perpendicular, you can assume the bisecting. The second one says perpendicular and bisecting, therefore you can assume the diameter, okay? All right, so in the figure below, okay, do we have a diameter? Yes, okay, because you know the line is passing through F. Is it perpendicular to the chord? Yes. All right, then that means that we know DE is congruent to EB. That's what the theorem says. If we have two things, we know the third, okay? All right, so it says that DB is equal to 12. Well, if DB is equal to 12, what's DE? What's EB? Okay. FE is equal to 8. Find the length of FB. They want us to find this length. Ideas. Pythagorean theorem. We're going to make this our C. 6 squared plus 8 squared equals C squared. See what you can do. It should work out perfectly. On this one, again, you look at the picture. Do you have a diameter?
Yes.
Do you have a perpendicular? Yes. Then that means you know tick, tick. It tells us that DB is 40. What's DE? What's EB? It tells us that FE is 8. Oh, 8 less than FB. Sorry. Thank you. My literacy skills, I got to work on that. Okay? All right, so if this is 20, 20, and then 8 less than FB, what are we going to make FB? If we don't know what it is, X. Okay? FE is 8 less. X minus 8. Okay? Use the Pythagorean theorem again. See if you can solve for X. You are going to have to FOIL. All right, just catching up with ya. Hopefully you're doing X minus 8 quantity squared plus 20 squared equal to X squared. Okay. After foiling, X squared minus 16X plus 64 plus 400 equal to X squared. You can cancel the X squareds from both sides. Take the 64 and the 400, move it to the other side. I got negative 16X is equal to negative 464. Everybody good so far? Okay, what does X equal?
29.
I heard a 29. Can I get somebody to verify that? 29? 29? All right, so we got several people that said 29. Anybody have problems with that? Okay? All right, so then let's make sure that we answer the question. What's the length of FB? 29. Okay? Next, What's the length of AE?
42.
I heard 21, 50, 42, 42.
It's 8 less than, look, if it's 8 less than 29.
Okay, so FE is 29 minus 8, which is 21. Okay, here's the question. What's AF? What's AF?
She said what FE is. FE, yeah. You asked what FE is.
Well, no, I said,
Wait, does that
if I said FE, sorry. I want AE because I said FE. Okay, sorry. FE is 21. Okay. 29 minus 8 is 21.
You know, it's just confused because Mary said 42, but you're talking about the whole length. I thought you said the FE only.
Okay, sorry. I apologize. All right. FE, do we agree, is 21? 29 minus 8 is 21. All right. What's AF? 29. And the reason we know, tick, tick, radius, radius, right? So now, let's answer the question. What's AE? 50. So AE is equal to 50. Okay? It just comes down to plugging things back in. Okay? All right, last theorem. Two chords are congruent if and only if they are equidistant from the center of the circle. What that essentially means is tick, tick. So, if KJ is the same distance away from the center as FE, then they're equal to each other. Okay? Okay, so in the situation that we have here, it says that CG is congruent to CH, and they are both equal to 4. 4, 4. They're the same distance away from the center. Okay? CE, they already labeled as 5. They want to find the length of KJ. Well, the concept here is, if you can figure out what HE is, and then use that to figure out what FE is, well, FE is equal to KJ. So let's start with the first part. Does anybody know what HE is? It's not 4, and it's not 5.
Is it 9?
It's not 9.
Is it 5?
It's 3. You forgot to take the square root. Okay? So, taking a look at this little triangle right here, what type of triangle is that? Right triangle. Are you using the Pythagorean theorem?
Yeah.
And you got x squared plus 4 squared equals 5 squared. And 25 minus 16 is 9, but then you got to take the square root, and we get this to equal 3. Okay? Now, do you see how CH is coming from the center? So it's part of the diameter. It's perpendicular to FE, which means, based upon our previous theorem, tick, tick. So what's the length of FE? 6. And based upon the theorem that we just wrote down, two chords are congruent if they're the same distance away from the center. What's KJ? KJ is 6. Okay? All right. So, you have another example very similar to that. See if you can do example number 5. So the first thing you should say is tick, tick, CG equals CH. They're telling you that KJ is equal to 7. Okay, so do you understand that HE here is 3.5?
Yeah.
Okay, do you understand that it's asking you to find the measure of angle HCE, this angle at the center? Okay, so now, if I were to label 3.5 as opposite, adjacent, or hypotenuse, what would I label it as? If I were to label the 5 as the opposite, adjacent, or hypotenuse, what would I label it as? Hypotenuse. Okay. What trig function uses opposite and hypotenuse?
Sine.
Sine. So we're gonna do sine of angle HCE is equal to your opposite 3.5 over 5. Do you remember how to find your angles? You do the negative sign. Very good. Okay? So angle HCE is equal to sine -1 inverse of 3.5 over 5. Type that into your calculator. Tell me what you get. $44.4. Okay? We'll just round it to 44 degrees to make it easier. Okay? So it's equal to 44 degrees. Okay? All right, so now, reminder. We're using that so that we can find the measure of arc FE, this arc, which means that if I draw in this line, what's the measure of this angle right next to it? 44, okay? So if this angle is 44 and this angle is 44, what's the measure of this arc?
88.
88, based upon what we learned yesterday, that the arc is equal to the angle at the center. 44 plus 44 is 88. Okay? That was a tricky one. But the ones down at the bottom here. Okay? All right, so one of the theorems that we learned today dealt with the idea that if, determine if PR is the diameter. Okay? So if you recall, I said there's 3 things that you need, or there's 3 things, right? And you need 2 out of the 3 to assume the third. What were the 3 things?
Diameter, bisect.
Diameter, bisect, perpendicular. Okay, so they're asking if it's a diameter, which means we need the other 2 things. We need bisect and perpendicular. Do we have both? No, we don't have both. Okay? And so therefore, since we only have one of them, this cannot necessarily be a diameter. Think about it this way, okay? You always have to think about what are some other possible cases. Well, if I have this chord, is it possible for me to bisect this line without using a diameter, like so? Tick, tick. Is that possible? Yes. Okay, so therefore the blue line doesn't necessarily have to be a diameter to cut it in half. But in order for the blue line to be a diameter, it would have to be perpendicular and bisect, okay? All right, so over here, 3 things: diameter, perpendicular, bisect. We need 2 out of the 3. They're asking you if RP is the diameter. So do we have bisect and perpendicular?
Yeah.
We have perpendicular. Do we have the bisect? Do we have tick, tick anywhere? No. So there's not enough information, so therefore, again, it's no. Okay? So just to show another example, if I do the following, okay, I draw a chord and I draw another line, okay, and we'll call it AB. And I go right angle, tick, tick. Is AB the diameter? Yes, because I'm showing bisect and perpendicular. I'm showing both. Okay, you have to have 2 out of the 3. Okay? Questions?